Here in section 4.3, the next thing that we want to look at is the graph of the basic logarithmic function. And so what we're talking about is y equals log base a of x, where a is greater than 1. And for convenience, you might think of a as equal to 2, or another common base that we'll see starting in the next section is base 10. But any number greater than 1, the basic shape will be the same. So there are actually two ways that I want to show you this graph. In just a minute, we'll make a table and plot points. But before we do that, let's remember how to graph an inverse function. And so we learned in this section that log base a of x is the inverse of the exponential function a to the x. What does a to the x look like? If a is greater than 1, it looks like this. So this is y equals a to the x, where a is greater than 1. Again, it might be convenient to think of a as equal to 2 or 10 or some other fixed number. So in section 4.2, we learned the graph of the exponential. And now in this section, we learn that the logarithm is the inverse of that. How do you graph the inverse? In section 4.1, we learned that the inverse is just a reflection over the line y equals x. And so I've just drawn in y equals x as a dashed line, and then I can just reflect over that line. So here is the y-intercept at 0, 1. It's going to become an x-intercept at 1, 0. And then the horizontal asymptote out to the left becomes a vertical asymptote shooting down. And then we have something like this. So this is the graph that we're interested in. It's log base a of x, where a is greater than 1. And it has a vertical asymptote at x equals 0. And just for the sake of completeness here, let's label the horizontal asymptote on the exponential. And let's also label the intercepts on both graphs. Okay, so the new graph is the graph in blue, and let's just see it another way. Let's look specifically at log base 2 of x, and let's fill in a table and plot some points. And so in the table you have log base 2 of 1/4. Do you remember how to do that? That's 2 to what power makes 1/4? 2 to what power makes 1/4? 4 is 2 squared. So we have 1 over 2 squared, which is the same as 2 raised to the negative 2. So that's a nice review of evaluating logarithms that we learned in the first video in this section. Okay, well, we can go on here, and I bet you'll say negative 1 and 0 and 1 and 2 and 3. And you could show the work. I won't write it all out for each of these, but there's one more. Okay, and so we can go ahead and plot those points. We can plot negative 1/4, negative 2, which would be about right there. And then 1/2, negative 1, 1, 0, 2, 1, and 4, 2. We're getting the shape that we expected based on what we know about the reflection over y equals x. We can connect these up with a nice smooth curve. And we have a vertical asymptote here at x equals 0. We have an x-intercept at 1. What is the domain for this function? From left to right, we can see that the input is always a positive number. So all positive real numbers, or in interval notation 0 to infinity. That's exactly the range of the exponential function, of the inverse, right? So when we talk about inverse functions, x and y switch, that means that the domain and the range switch. What's the range of this function? From the bottom to the top, we see, looking from the bottom to the top, we see that the y value could be any real number. We can write that negative infinity to infinity, and of course that's exactly the domain of the exponential function. There is, for this graph, there is no y-intercept. Okay, so that's an important graph. Let's generalize just a little bit, and I guess this is a little bit redundant. This is the graph that we looked at in the beginning here of the video. So we'll just sketch it again real quick with x-intercept at 1, vertical asymptote at x equals 0. This is the new basic function. Okay, and then in example 5, let's sketch a transformation of that function. So we have f of x equals log base 4 of x plus 2. So what's the basic function? You could write log base 4 of x, or you could generalize just a little and write log base a of x, where a is greater than 1. And then the transformation is this plus 2, and that's inside the basic function, right? That happens before the logarithm. So that's going to be a horizontal shift to the left 2. Shift left 2. And then we can go ahead and sketch that graph. You might want to pause the video and try to do it yourself. Okay, so there's the basic function. If we're going to shift this thing to the left 2, then you might like to start with the x-intercept at 1, 0. If it goes to the left 2 over 1 and then 2 units, then it's going to end up at negative 1, 0. The other thing that we really want to shift here is the vertical asymptote. When it comes to the left 2, then we have a brand new vertical asymptote at x equals negative 2. And then we can just go ahead and draw the curve through the point at negative 1, 0 and approaching the vertical asymptote, and try to make it look as much like the first curve as possible. Okay, and then there's our graph. We'll just label it f of x, and we're done. Okay, there's one more thing that I want to say before we go on. So let's pause for a moment and let's talk about 11 basic functions in college algebra. We've been studying them in Chapter 2, Chapter 3, and Chapter 4, and we finally have the whole list. So let's write them out. Let's write y equals x, y equals the absolute value of x. Let's write y equals x squared, y equals x cubed, y equals the square root of x, and the cube root of x. Those were the first 6 that we learned in chapter 2. And then in chapter 3, we learned about y equals 1 over x and y equals 1 over x squared. And now here in chapter 4, we learned y equals a to the x, where a is greater than 1. And we also learned y equals a to the x, where a is between 0 and 1. And now, just now, we have the last in the list, which is y equals log base a of x, where a is greater than 1. You may have noticed that we haven't spent much time talking about logarithms where the base is less than 1, and so that's okay. If you're interested in that graph, then you can find it in the textbook. Okay, so take a moment, pause the video, and then see how many of these graphs you can sketch. Do you remember them? I don't think there's a lot to say here, but it's certainly nice for you to see them all together in one place. Starting here with number 7, we should be labeling asymptotes. And then we go to number 9, and we have the exponential function that we saw at the beginning of this video. In number 9, the graph is increasing. In number 10, the exponential graph is decreasing. And the last one. Indeed, graphing is one of the major themes of this course, and as long as you keep taking math courses, graphing will be an important part of those courses. So these 11 graphs will serve you well in your future studies.